We designed this telescope to see the very first galaxies that turned on in the universe, and when we saw what it did in only 12 hours, we knew in our hearts that whatever's out there, we're going to see it.
The James Webb Space Telescope, NASA's highly anticipated successor to the Hubble Space Telescope, is rewriting our understanding of the universe. One of its groundbreaking achievements is the recent detection of a structure dating back an astonishing 13.8 billion years, just a few hundred million years after the Big Bang. A structure in space that seemed older than the universe itself. This revelation raises more questions than it answers. But how possible could a structure be older than our universe, or is the Big Bang theory at fault? Join us as we embark on an adventure guided by the revelations of the James Webb Telescope. Let's uncover the mysteries of a structure that is 13.8 billion years old. In a momentous event, the James Webb Space Telescope detected a structure that dates back an astonishing 13.8 billion years. This finding places the structure's formation within the first few hundred million years of the universe's existence, making it one of the oldest known objects ever observed. You must be wondering, though, how the James Webb Telescope could possibly find a structure that is older than the universe itself. First, let's take a closer look at this structure to find the answer. It's not a black hole, a nebula, or a galaxy. It's a star, a very ancient and unique star, known as HD 140283. It is situated in the constellation Libra, around 190 light-years from Earth. A star that old is certainly interesting, particularly when it is so close to us. It can be seen with binoculars, however, that appears to put it older than the universe. Not only is this star old, but it also moves fast. It travels quickly through the sky at 800,000 miles per hour, or 1.3 million kilometers per hour. What's more fascinating, though, is that HD 140283, or Methuselah as it is more well known, is among the oldest stars known to scientists. Using data from the European Space Agency's Hipparcos spacecraft, scientists attempted to date the star in 2000 and came up with an estimated age of 16 billion years. Such a figure was rather mind-blowing and also pretty baffling. According to studies of the cosmic microwave background, scientists has calculated the age of the universe to be 13.8 billion years old. It was certainly clear that Methuselah, named in reference to a biblical patriarch who is said to have died aged 969, making him the longest-lived of all the figures in the Bible, was old. Since the metal-poor subgiant is predominantly made of hydrogen and helium and contains very little iron, its composition meant the star must have come into being before iron became commonplace. However, older than the environment by more than 2 billion years. That simply cannot be possible. This discrepancy raised questions regarding the age of the universe, the star, and the accuracy of dating methods. Is this star a remnant from another universe? Is the universe older than we now believe? Could our dating methods be flawed? Let's investigate each of these possibilities in more detail. The standard estimate of the time since the Big Bang is 13.79 billion years. The figure has been validated by multiple ways, but it is derived from the rate of expansion of the universe using Einstein's relativity. However, that number is now facing at least 3 distinct challenges. The existence of stars that are thought to be either older than 13.8 billion years or so near to that age that there shouldn't have been time for them to form is used by proponents as proof. One of the primary claims against HD 140283 is that it disproves the Big Bang theory. After all, if there is even one star 14 billion years old, then the explosion that started the universe couldn't have happened less than 14 billion years ago. Since the Big Bang is now so crucial to our understanding of the universe, its denial would spark a scientific revolution unlike anything we have seen in a very long time. A smaller, but still dramatic change would be required to adapt to the recent claim that the Big Bang happened, but almost twice as long ago as most estimates put it at 26.7 billion years ago. Although astronomers are not particularly in favor of either theory, some do believe that the universe is actually 15 billion years old, and that our estimations of the Big Bang's chronology are slightly incorrect. Although such an estimate would raise a few questions about why our estimates for the universe's expansion rate are out if proven, accompanying changes to our thinking would be evolutionary, not revolutionary. It is interesting considering in that context why we might not anticipate finding 20 billion-year-old stars if the universe were 26 billion years old. Although scientists have only truly examined a small percentage of the galaxy, Methuselah appears unusually young if the universe is that old. Then take that question a step further and ask what we might expect to see if the universe had no beginning and has always been here. Beyond our own Milky Way, the stars in the globular cluster M92 are estimated to be approximately 13.8 billion years old, and while the age of some very distant galaxies has been detected by James Webb Space Telescope, nothing appears to be significantly older than HD 140283. There are many measurements that suggest the age of the universe is about 14 billion years, in regard to the 26 billion-year-old. In addition to the cosmic microwave background and the supernova measured expansion rate, there are other factors to consider, such as the universe's large-scale structure and the age of the oldest stars. Lastly, it should be noted that while modern techniques for determining star ages may be more accurate than the 969 years that the biblical Methuselah is said to have lived, but they're far from definitive. Quoted error bars don't necessarily include all potential causes of error. HD 140283 is a prime example. Depending on which estimate of its mass is accurate, another team came up with Methuselah star ages of about 13.7 billion and 12.2 billion years, in addition to the 14.46 billion estimate. According to yet another study, 12.0 is most likely the age of this star. Clearly, the last two values pose no threat to a 13.8 billion-year-old universe, and even 13.7 billion can be explained through the error bars. The absolute brightness and composition of stars are typically used to estimate their ages. All that was present in the early universe was hydrogen and helium. Only the first generation of stars' death produced the majority of the heavier elements. The star is thought to be older if the concentration of these elements is lower. Still, this isn't an ideal approach. Not only can we make mistakes in measurements, but the heavy metal products of the first supernovas may not have always mixed evenly. Other methods have been proposed, but are still being validated. According to some estimates, there is a 70% chance that the age of the Methuselah star is between 13.66 and 15.36 billion years. The lower bound of this range is consistent with the estimated age of the universe, which is about 13.8 billion years. However, there is also a 30% chance that the star's age falls outside this range, with a 15% chance that it is even lower. Taking everything into consideration, there is a 20% chance, or less, that the star is actually younger than the universe itself. It's comparable to rolling a regular six-sided die and, although unlikely, getting a 6. But this also assumes that there are no other sources of error or bias in the age estimation. Nevertheless, it is undeniable that the Methuselah star is incredibly ancient. With a fairly precise age estimate, It is the oldest star in the entire cosmos. The detection of Methuselah star holds profound implications for our understanding of cosmology. It provides a glimpse into the formative stages of the universe, offering a window into the cosmic processes that laid the groundwork for the galaxies and structures we observe today. The early existence of such ancient structures challenges previous assumptions about the timeline of cosmic evolution. The discovery prompts a re-evaluation of current cosmological models, driving astronomers to refine their theories to better align with the observed reality. Furthermore, the James Webb discoveries enhance the continuing investigation into the nature of dark matter and how it influences the structure of the universe. The complex interaction that occur between dark matter and visible matter in the cosmic filaments offer important hints for solving the secrets surrounding this mysterious material. Future studies using the jwst may delve deeper into the properties of cosmic mysteries, shedding light on the intricate details of their formation and evolution. Additionally, the telescope's capacity to study exoplanet atmospheres, distant galaxies, and other celestial phenomena promises a wealth of discoveries that will broaden our understanding of the cosmos. I hope you enjoyed this video. Don't forget to hit the like button and subscribe to our channel for more interesting space-related content. Thank you very much for watching, and I will see you in the next video.